Hello, this is Mr. Stansbury. I'm going to take you through the notes on the area of a triangle. At the end of this, you should be able to say, I can find the area of non-right angled triangles. Okay, so first thing, how to label triangles. We normally label angles with capital letters, so capital A, and then across from that angle, the side of a triangle would be lowercase a. So across from big B is little b, across from big C is little c. Okay. Also, area of a triangle. Area is 1/2 base times height. Okay? Now, we will often have angles and sides of a triangle, but not the actual height. So we need, in order to use this formula here, we need the base, which in this case would be CB, and then we also need the height, which would be AD. Okay? So, if we label everything here. So here across from big C is little c, across from big B is little b, across from big A is little a, this whole thing here. We're just calling that point D. We know that the base here is going to be side A, this right here. The height is going to be H. Okay. Now, here's the cool thing. So like, let's say here is sine of C. So we're going to call this is going to be our angle. Okay. So sine of C is the hypotenuse, the opposite side over the hypotenuse. So in this case, the opposite side is H and the hypotenuse is B. So the sine of C, angle C, is going to be H over B. Okay. Now, if we multiply both sides by B here, so if we just did this, multiply by B, these B's go away, and we just simply have H equals B sine C. So here it is, H equals B sine C. Okay. So we could also write the area formula as, instead of 1/2 base times height, we know that the base in this case is going to be A. So 1/2 of A, the base, and then the height is going to be the sine of this angle. So sine of C, angle C, sorry. So we've got the height is going to be B. Let's just go straight with our formula here. Height is going to be B sine C. So what we're going to do is we're going to replace this height here with B sine C. Okay, so that just goes right into that spot. This height here is B sine C. So the area is 1/2 of AB sine of C. So if you have an angle, and then we know, if we know the two, let's see, A and B, if we know the angle and the two sides that include that angle, that make up that angle, then we can find the area of that triangle, even if it's not a right triangle. Okay, so let's do this. Oh, sorry, we have another way to look at that is, in case you didn't if you had like an obtuse triangle like this instead, this will still work. Base is still going to be A, height is still going to be this H here. So really basically what it does is it's the sine of the this angle right here is going to be 180 degrees minus whatever this angle C is here. So there's our sine of 180 minus C here. Okay, is going to be the height over, in this case here, the base. Okay, sorry, the height over side B, not necessarily the base. Okay, so anyway, ends up being the same thing. Area is 1/2 AB sine C. Area is 1/2 AB sine C. All right, so let's put that to some use. Find the area of the triangles. Okay, so we have, what we're looking for is the angle and the two sides that make up that angle. Okay, and if you remember our area formula, area is 1/2. Let's look at it back here. AB sine C. Okay, AB sine C. So basically, here's what I like to think of these as. So these here are the two sides that make up the angle. Make up angle C. Okay, so there's angle C, and then these are the two sides that make up angle C. So here's our area, would be 1/2 19 and 27, not the side that's across from the angle, but the two sides that make up the angle. So 19 and 27, doesn't matter which order we put them in. Okay, and then sine of this angle 87 here. Okay. If the 87 happened to be in here, then it would be 1/2 of, and then we do say 29 and 27 sine of 87. If the 87 was over here, it'd be 1/2 19 and times 29. So it's just the two sides that make up that angle. Okay. So we can put this into our handy dandy calculator and see what we get. So we do 0.5 times 19 times 27, and then the sine of 87, and that gives us 256.1. We'll go with 256.1, and this is in meters, so it's area, so it would be 256.1 square meters. Okay. All right, let's do another one here, but first let's do a little comedy break. All right, let's look at this one here. So area 1/2 AB sine C. So again, if you look at the letters here, what I normally do for this thing here is I'm going to get rid of these letters, and I'll just reassign them the letters that I want. So the angle that they gave us, that's going to be C, and then I'll just call the other one, say A and B, doesn't matter, and then I can fill everything in that way as well. Okay, so area is going to be 1/2. It's the two sides that include the angle, so let's do 8 times 6, and then we got sine of 39, and that will tell us what the area of this lovely triangle here is. All right, so let's do this. So 1/2 of 8 is 4 times 6, and then we got sine of 39, and we get the area is 15.1, and this is millimeters squared. Okay. Okay, example 2. A triangle has two sides with lengths 25 centimeters and 18 centimeters and an area of 211 centimeters squared. Determine the two possible measures of the included angle. So this obviously means a triangle that has two of the sides that have these lengths, because a triangle has to have three sides, hence three angles, hence triangle. So anyway, let's draw ourselves a picture. So drew a triangle here, just said let's make that 18 centimeters, this is 25 centimeters, and this is the angle that we're looking for, right? So we know that our area formula is 1/2 AB sine C, right? So in this case here, we actually know the area is 211 centimeters squared equals 1/2 of, say, 18 times 25 sine of C. So what we got to do is we got to figure out what this here is, and we will be able to solve for sine C. Okay, so let's do 0.5 times 18 times 25, and that gives us 225. So we get 211 equals 225 sine C. We got to get sine C by itself, so we got to divide both sides by 225. Right, so we get sine C equals whatever 211 divided by 255 is. So 211 divided by our answer. That's not what I wanted. So 211 divided by 225 gives us 0.9377. Okay, so now, if you remember, in order to get an angle, for solving this thing for an angle, we have to do second sine to figure out what angle C would give us, right? So what we'd want to do is just do second sine of this here. Instead of entering our rounded number, let's do this second entry, second answer. That's what I wanted. And that will give us 69.68, so 69.7 degrees. Okay, so that would be one that works. Now, we also know that if we know that the supplement to this angle will also work for sine as well, right? So what we're going to want to do, 69.7 works, and then also, or C could equal 180 minus 69.7. So 180 minus 69.7 would give us, it could also be 110.3 degrees. Okay, so those would be the two possible angle measures that would work for this triangle here. Okay? All right, that's all there is for the area of a triangle. If you have any further questions, please feel free to ask in class. Thanks.